So, as we have studied and learned the previous sections, it is important that now we go through into the inverse functions and relations. Remember, we managed to talk about the difference between these two functions and relations from the vertical line test. We saw that if a vertical line is to cut the graph at a single point, then that graph is referred to as a function. When it is to cut the given graph at 2 points or more, then that graph is now referred to as a relation. So those functions, those relations, they have got their inverses. They have got their inverses, which is actually uh, a reverse of the original function. So an inverse of a certain function happens or occurs on a condition where that function or relation, the graph that we're talking about, has been reflected in the line y is equal to x as our mirror line. All right, on the line y is equal to x passing through the origin. So when a graph is reflected along this line of y is equal to x, we are having or obtaining its reflection in actual sense. A reflection in the line y is equal to x. So let's say we've got a point, guys, which is here. And this point lies in the x-axis at a point 3. We are saying if this point is at this where it is here, its coordinates, it was what? It is 3, 0. So when we are talking about a reflection along this line y is equal to x, where are we going to find the image of this point 3? So it is going to move towards the line, all right, produce a 90 degrees. So this distance that it moved going up, all right, this is the distance. It is the same as the distance that we are going to have this side. So it's going to be at a point what? At a point 3, which is in terms of x, because we are in the y-axis, x is equal to 0 there. Then y is 3. So a reflection of the line y is equal to x, as we can see, it reverses the points, meaning to say what was 3 in x, it is now 3 in y. What was 0 in x, it is now, what was 0 in y, it is now 0 in x. So that is the condition of inverse function that is going to happen. So when we are talking about any function as an inverse, guys, this is what is going to happen. So meaning to say, for inverse functions, before we talk about how to determine those inverse functions, if that is what is happening in terms of the points, to say points change in this manner, x to y, then y to x, it means they have got reversed pairs of xy, meaning to say reversed domain, meaning to say reversed range in that manner. Because, guys, let's say you're talking about range. Those are x values from 0 to 3. So what was your range will change to be the domain of the other one now when we're talking about inverse function, because we have reversed what was x. It will be represented as y. Remember, domain are x values. So it just reverses, domain becomes range. So that is another condition that we're going to look into. So in actual sense, we are saying inverse functions or relations, they have got what? They have, all right, so they have reversed ordered what? Ordered pairs. Ordered pairs. which means we are talking of what? That XY concept. It is reversed, therefore reversed domain. Therefore reversed domain. Meaning to say, thus, the domain of one becomes the range of the other. All right? The domain of one becomes, remember, domain, we are talking about x values. So x values, they are now reversed to y values. What represents y values? It is the range. So it becomes the range, which are the what? The y values, okay, of the other, of the other. All right, just like that. And that's a vice versa. If it is the range of the other one, it will change to the domain. Because that is the condition, guys. X is changing to y, y is changing to x. So that's the condition. That's the condition. So in terms of graphs now, for us to properly give the equation now, guys, we cannot do it in terms of the graph to say, okay, let's say we have got a graph like this, then we have to represent that graph. We draw the line of y is equal to x, then we say, okay, this is the graph that we have as a reflection. This one, it is just for our understanding to say this is what happens. That's the relationship that is going to happen between what is original and what is representing what? What is representing the inverse. It will be related as a reflection of what? Along of the line y is equal to x. It's a reflection along that line. So inverse function, they produce graphs that reflects over that line. They produce graphs which reflects over that. Those graphs, how can we determine their equations from the original one? That is the case. From f of x, we need to determine its inverse function. Its inverse function. How so? So these are the steps that you're going to simply need to determine the inverse. All right. So to determine the inverse, we just need two steps there. So to determine the inverse function of any graph, the inverse, to determine the inverse of any graph. All right. So one, we are going to first interchange x and y. From that equation that you're given, please interchange what? X and y. Then from there, you make y the subject of the formula. Make y the subject. Make y the subject of the formula or equation. So that is the case. The equation that you're going to find there, that's your inverse. That will be your inverse. You simply interchange just like that. That is the condition, guys, to find the inverse of any function that you're going to be having in your syllabus. So let's say, for an example, using this, let's say, all right, for these questions, we are going to be finding the inverse of every part, all right? So we are going to find the inverse of each, all right, of each question that we are going to have from now onwards. All right, let's just say we have got the original equation given as y is equal to 3x plus 2, a linear function, a straight line, and we want to determine its inverse. The inverse of a straight line is also a straight line. Inverse of a straight line is also a straight line. But how can we determine the inverse of this? We said from these steps, number one, you just need to interchange x and y. You interchange these two, x and y. All right, so interchange x and what? X and y. So meaning to say, it's going to be x is equal to 3y plus 2. x in place of y in place of x. After that, make y the subject, just like that. After that, make y the subject. By making y the subject of the formula, we have our inverse. To make y the subject of the formula, it simply means solve for what? Solve for y. As if you're solving for x in all those normal equations, you solve for y. That's the case. So how can we solve for y in our equation? What is affecting y? There is a plus 2. So we're going to take it to the other side of the equation. So it'll be x minus 2 equal to 3y. Remember, we are solving for y. We need to know what is y in terms of x. There is a product. So how do we get rid of the 3? Simply divide by what? Simply divide by 3. By dividing by 3, we have got our y as the subject of the formula. Y is equal to x minus 2 over 3. Just like that. Just like that. So that's our inverse, which is a straight line. If you have to rewrite in that format of a straight line, y is equal to x over 3 minus 2 over 3. Each and every part is divided by what? By 3. So it's a straight line. That's the inverse of x, the inverse function. X minus 2 over what? Over 3. Just like that. Those are the two stages. Interchanging x and y, then making y the subject of the formula. Just like that. So you see now, because of different types of equations, how are we going to make x the subject? I mean, y the subject of the formula now will depend with what you're given. It is not always where it is going to be a straightforward thing, just like what we had on this other part. All right, let's say we're given a logarithmic y is equal to the logarithm of x in the base of a, like that. We want to find the inverse of this graph. Remember, the first thing is to interchange x and y. So that's the first part, interchange x and y. So now x is equal to the logarithm of y in base of a. Then from there, we are supposed to make y the subject. How can we make y the subject of the formula? From a logarithmic function. How is that possible? Thus, understanding conversion between a log and exponential is useful at this moment. Remember the ABC concept. ABC concept. The logarithm of A in base of B is equal to C. Will give us, which also can be reversed back here. A is equal to B to the exponent of C. A conversion made between a logarithmic and an exponential. This can be used, ABC concept. Log A base B is equal to C. A is equal to B to the exponent of C. So that's why we just call it ABC concept. So we have a log there. So best rewrite it in this moment so that you can properly see. Not to say you cannot see it when it is written like this, but you can just, okay, I want to properly write it in this manner so that I can see exactly what is my A and what is my B, what is my C. All right. We did not change anything. We never changed anything. It is as it was here. So now let's consider this idea. What are we saying? A represents what? That's our Y in this case here. So therefore, y is equal to what? B to the exponent of C. The b is the base, our a to the exponent of what? To the exponent of x as it is. It's a conversion from our logarithms. So as we can see, guys, in simplifying from a log to an exponential, in doing so, y is the subject, or y, we have already made y the subject of the formula, guys, which is what we want, which is what we need from this. Y is already the subject of the formula. That's exactly what we want. So therefore, the inverse of x is a to the exponent of x. So we can see that from a logarithmic graph, its inverse is an exponential. We started with a logarithmic graph, but what is it that we have at the end? The inverse, exponential, which is different from what we saw on a straight line. On a straight line, its inverse, it was a straight line again. But a log, it is giving us something else, exponential. That's a vice versa also. The inverse of an exponential function will give us what? A logarithmic function. If you understand this, you're done. You're done. So we are going to look into another question, which is changing an exponential to a logarithmic. All right, so let us see another type of a logarithmic. It can be given as ln of x, ln of a certain number, whatever that you're given, is still a logarithmic that you are given from our Napierian logarithms. So let us say number 3, y is equal to ln of x. We are still finding the inverse. So here the ln, remember ln as just having that log, ln, it represents the logarithm in the base of e. So ln of a certain number, it is the logarithm of a certain number in the base of what? In the base of e. So rewriting this ln that we are given here, it simply means y is equal to the ln, the log. So we are now changing to the log. So it is the log of x, ln of x, log of x. But the base, it is a special base of e. So if you notice, we are back to that question that we had before, which had a log y is equal to the logarithm of x in base of a. The difference there is only the base. So ln, they won't tell you that, guys, use log base e. You must know that. Ln of a certain number, it is the logarithm of a certain number in that base of what? In the base of e. So guys, here we are just rewriting the question. We are not solving, we're just rewriting. This is exactly the same. So now let us find the inverse. We are back to those steps. What are the steps? Interchange x and y. All right. So let's interchange x and y. So meaning to say, if we interchange our x and y, what are we going to have? X is now equal to the logarithm of y there in base of e. So this can be used, the conversion from a log to an exponential form. Like I said, you can write in the way that you understand. Start with the log y base e is equal to x. We did not change anything, we're just rewriting. So therefore, y there representing our a is equal to, so y is equal to what? The base to the exponent of c, the base, which is e, to the exponent of what? To the exponent of x. That's our inverse, which is also an exponential function. So that's the inverse of x, which we are seeing here. That's our inverse function. Y is equal to e to the exponent of what? Of x. You must, as an individual, Revise as many questions as possible. As possible. All right, let's consider another question. Now let us just try to change exponential function and see if truly its inverse is a logarithmic. Just like I said, if we are to find its inverse, we must have it what? As a logarithmic. All right, let us consider this as our example number 4. Still finding the inverse of our functions. Let's say we are given y is equal to 2 to the exponent of x. It can be e to the exponent of x, 11 to the exponent of x, 100 to the exponent of x, one and the same thing throughout. All right, how do we simplify such? The first thing is to interchange x and y. First step, interchange x and y. So x is equal to 2 to the exponent of y. From there, make y the subject of the formula. Make y the subject of the formula. How is that possible? Look where y is on the exponent. How is that possible? How is that possible? From that conversion of a log to an exponential, now we do the vice versa. From here, it can be, it is just like on those reactions that we have in our physics, which can be taken from one point to another, reversible reactions. So it is the same thing. We can move from log to exponential. We can move to another, vice versa. So now we are moving from exponential to log because we have an exponential. Can we rewrite it as a log? By rewriting as a log, we are making y the subject. Look, y is the exponent, just like c. C is our exponent. But when we rewrite it back here as a log, you see, c is what? It is the subject of the formula because we are saying c is equal to. So it is what? It is the subject of the formula now. That is what we simply need. That is what we need. So it is logarithm of what? The logarithm of a. Our a is the one that we are saying. A, okay, let me write it. Yes, let me write. A is equal to b to the exponent of c. So it is the logarithm of a, the logarithm of what? Of x. In the base of b, what is our b? Our b is 2. It must give us what? C, where our C is what? Where our C is y. Guys, look. Log x base 2 is equal to y. Y is the subject. This is what we want. We want to make y the subject of the formula, remember. Y is the subject because we are saying y is equal to. Y is on its own. It is the subject of the formula. So that's our inverse function of x there that we are talking about, log x base 2. So as we can see, it is truly what we expected to say. The inverse of an exponential is what? A log. As we saw, a log changing to what? A log changing to an exponential. So an exponential changes to a log as what? As an inverse. As an inverse. So this is what you need, guys. Just go through your basics question papers. So some of these questions that I'm inserting, they're actually from question papers where they want you actually, some they were to draw the graphs. But in this case, we are focused on finding the inverse. What is actually the inverse of a certain graph? From the original one, you can determine the inverse. All right, let's consider this as our question number 5. Y is equal to, which is y is equal to the square root of 36 minus x squared. When there is no plus or minus, it represents a semicircle. We're going to talk about that one later on, but that's the equation of a semicircle. Equation of a semicircle. When we are given a semicircle, we are going to, let's say the question is for you to find its inverse. Its inverse. All right. So from that, we can simply work with the way that we had previously when interchanging x and y. So if we interchange x and y, x is equal to the square root of 36 minus x squared, minus y squared, sorry. We interchanged it there, so it's now y there. Then we make y the subject of the formula, make y the subject. So what are we going to do? We have to square both sides. It's under the square root, so we're going to square both sides. So it's going to be x squared equal to 36 minus y squared. Squaring that is just removing the square root. So we can make y the subject of the formula. Look where y is. We can take it to the other side of the equation. So it's going to be positive y squared. We take the x squared to the other side. So it is going to be negative. So it will be 36 minus x squared. 36 minus x squared. All right. But what we need there is to find y. All right. We need to find y to make y the subject. So what I'm going to do, we have to introduce the square root. All right. So if we introduce the square root in that case, this is what we are going to have. It's going to go back to the original one. I want you to see y is equal to the square root of this. So this was of y. What about when it is of x? Because it was the square root as it was there. So this one, it will still be the same as what we had originally, the square root of 36 minus x squared. So if we look into that one in a normal way, it is like there is no inverse there, because what we had on the original, if we interchange, it goes back to that original format. So what then can we do when we are to find the inverse? Because there it is giving us exactly our original function. So you are going to notice this. I want us to be careful for these ones going on. When we are given a semicircle, we are referring to a semicircle, we are referring to an ellipse. They have got the same format. In those, to find their inverses, you just interchange x and y. It will be the inverse. You saw that by calculation, it goes back to the original function. So in actual sense, we'll be saying there is no inverse if we do it like that. But in a normal sense, its inverse will be just interchanging x and y, the inverse function. So that's what you're gonna do for semicircles. All right. It was actually from a circle, but you won't see it on a circle because let's say you're given x squared plus y squared is equal to 16. This is what I'm trying to say. You just interchange x and y for those. So if I to interchange x and y, it does not make sense, guys. It will be like y squared plus x squared is equal to 16. Still one and the same. I haven't changed anything. So you won't see the effect on a circle. But on a semicircle, you can see that interchange xy. If we interchange x and y, we are done. So it will be x is equal to the square root of 36 minus y squared. That step, it will represent what we refer to as the inverse. That will be the concept of the inverse. That will be the concept of our inverse function. So we can have these from our semicircles, like I said, all semicircles. We go to the application of our ellipse, also an ellipse. So that's why you see other textbooks, when they refer to the inverse, they will just say there is no inverse. Then later on, they'll ask you to calculate the inverse of a semicircle or the inverse of that. then they want you to have your answer in this manner. You are now, what is happening? From our normal calculation, it goes back to the original way, the way that we are used to, which is not what we need. So in any exam principle, when we are to find the inverse of a semicircle, you just interchange what? X and Y. All right, from a circle, but you won't see it on a circle. So a circle goes back to the original function. A semicircle, it will give us a semicircle as well, but what we just need there is to interchange X and Y. That is it. So if I'm given X is equal to minus square root of maybe 9 minus Y squared, this is my original function. I just have to interchange the inverse. I just interchange. So it'll be y is equal to minus the square root of 9 minus x squared. I'm done. I'm done. Just like that. All right. So those are the some of the exam techniques that you need in your syllabus as you are dealing with your syllabus. Guys, also know that you are working with a certain syllabus that you must follow, that you must follow. All right. So you are going to notice that in your calculations. So that is how it's gonna be like. So without wasting our time, if we're given y is equal to minus square root of 144 minus x squared. If we were to find the inverse, it was gonna go back to the original format the way that it is. So the inverse, just interchange x and y. So x will be equal to minus square root of 144 minus what? Minus y squared. That will be the concept. All right, that will be the concept of what I'm trying to say. Okay, so that is it, guys. Let's just do work out as many questions as we can. Then another part, we can be given even those quadratic functions. Let's say we want to find the inverse of y is equal to x squared minus 4. What can we do? All right, on this one, we just go back to the original way. First thing is to interchange x and y, number one. Interchange x and y there. That is x is equal to y squared minus 4. Then what that we do? We make y the subject, which is the second thing, is to make y the subject. So let's make y the subject of the formula. Take the minus 4 to the other side. It's going to be plus. So x plus 4 is equal to y squared. How do we get rid of the square? Simply introduce the square root both sides. So introducing the square root, that's y is equal to square root of any number is plus or minus. So it's going to be plus or minus x plus 4. So that's the inverse function to our x. So the inverse will be plus or minus the square root of what? X plus 4. All right. That's how it can be given as. That's how it can be given as. We just have to, guys, some of these questions we just have to be careful. All right, there's another question like this, which is also direct, but how direct it is, you can be confused with how direct it is. Let's say it's actually from an exam, this one. X is equal to 1 over 5 ln of x. Ln of y like this. It's an equation, but you need to find the inverse of this. The inverse. What is the inverse of the given function? So the inverse, as we need, okay, to make y the subject first so that we can see what was the original function. But from the concept, it is to interchange what? X and y and make y the subject. So if we were to interchange x and y, it was going to be y is equal to 1 over 5 ln of x. We interchanged x and y, then we want to make y the subject. Guys, what is happening? Y is already the subject. So we already have the inverse. Y is already the subject there. Y is already the subject. Okay. It might be, like I said, how direct it is also confusing how direct it is. But let's go back to the normal understanding. You know that x is equal to this 1 over 5 can be its original. In an original manner, we can rewrite. We want, because we are used to when y is the subject, isn't it? All right, so let's get rid of this 5, 1 over 5. So it's just going to multiply by 5, multiply by 5. So that's 5x is equal to the ln of y like this. Remember, the ln of y means what? Log in the base of e. So it is the logarithm of y in the base of e. We are just rewriting, guys. We want to make y the subject, the same equation. So y as our subject is equal to what? E to the exponent of what? E to the exponent of 5x. Guys, we are saying this equation x is equal to 1 over 5 ln of y. This equation here, it is the same as this one. It is just like we are given y is equal to 2x. Then someone divides this by 2 by 2, then write as x is equal to y over 2. So this is what happened. They gave you something like this, then they said, make, interchange that one to find the inverse. So it is like you are now rewriting to say, okay, what was it like before they made x the sub? Was here they made x the subject of the formula. So you want to know what was the original equation. Okay, just multiply by 2, isn't it? Just multiply by 2. You multiply by 2, you multiply by 2. Y is equal to 2x. You know, okay, this was my original equation. Then from that original equation, that's where now you find what? The inverse of that function, because you are used to, when you are given an equation in that form, when they say y is equal to e to the exponent of 5x, find the inverse. You are used to that. When y is the subject. So no problem. Write it in the way that you are used. Then find the inverse. Now, how do we find the inverse? We are now going back to those steps. Those steps, remember our steps. Interchange x and y, then make y the subject. Those steps, they are not going to change. Here it was just rewriting. We are at the normal format that we are used to. Now, we interchange x and y. Let's start with that. So what are we going to have if we interchange? It follows that it will be x is equal to e to the exponent of 5y. Then make y the subject. Make y the subject of the formula. From that concept, remember, of an exponential, a is equal to this. It follows that it's going to be logarithm of a, logarithm of what? Our a is x. So it's the logarithm of x in the base of b, where our b is e, and that is equal to what? That is equal to 5y. The exponent, which is 5y. Y is not the subject yet because it's 5y. We need it to be the subject. So divide by what? Divide by 5, divide by 5. So that's it. Y is the subject, which is this one over 5 simply means 1 over 5 log x in base of e. And remember, guys, log x base e means what? Ln. 1 over 5, the ln of what? The ln of x. That's our inverse. So that's y is equal to, which represents what? The inverse of x. Isn't it the same answer that we got there? The inverse of x. Remember here, 1 over 5 ln x. It's the same answer that we are getting. 1 over 5 ln of x. But there you had to rewrite in a normal format that we are used to when y is the subject of the formula. That is what we are used to here. You interchange x and y from there. You are used to that. Y is equal to x squared. Y is equal to x plus 1. Y is equal to y is, you are used to that. But it could be done direct here. Could have been done direct. As you interchange x and y, you make y the subject. But by making y the subject, it is already the subject. So there's nothing that we're going to do from there. Because what we want is to make y the subject. So as y is the subject, what does it mean? That's our inverse function. Just like that. Just like that. So I want you as an individual to go through some of the subsections. And also, guys, this is mathematics. Our understanding, even the textbooks, their understanding, it is an individual who has got a certain understanding. That's why you see there is no one textbook. There are different types because a certain person has got their own understanding. So if as an individual you also have your own understanding in this, that's where we've got our community section. Let's meet there. Let's communicate so that we can bring that into idea, and it can help us as students. Also, it can help others who are revising to say your way of how you view that question. You have got a certain view or a certain understanding pertaining that topic or that section. Just copy the link of the video, then bring that link to the community section. Then you explain what you think. Then I'm gonna find time to go through that. That can actually help as we are revising. So it is the community for the platform, not for me, but for you guys also to communicate. Or maybe there is a certain way that you think, or maybe the explanation does not tally to what you understand. Then we can explain why is it like that. All right, guys. So that is it. Let us do revise as we are preparing ourselves for the exams that are ahead of time. We need to revise as many questions, revise all topics, each and every subtopic must be done, because you are going to find something very, very small that you neglected in your revisions. Then you see it is affecting your finals. So each and every part of a topic must be done. So that's it, guys. Till we meet again.